Hello, PascoMath grade 8 teachers. Today we're going to be exploring 8.EE.1.3, unpacking the standard, looking at what the teacher could be doing in the classroom as well as what the student should be doing, and anticipating some misconceptions and how we can address those in the classroom. So let's get started. So the standard states, use numbers expressed in the form of a single digit times an integer power of 10 to estimate very large or very small quantities, and to express how many times as much one is than the other. So when we unpack that a little bit, there is an emphasis on scientific notation. Students need to write very large or very small numbers in scientific notation using positive and negative exponents. So this is building off our work with 8.EE.1.1. Students use the scale to determine and compare how many times larger or smaller one number written in scientific notation is to another. So let's look at what the teacher could be doing in a classroom. And so the first thing they can do is introduce examples of very large and very small numbers in context. There's a variety of ways to get numbers. You can look at government statistic websites. I got one right there, www.usa.gov/statistics. Population sizes, science connections, a lot of ways to get very large and very small numbers. Provide students with the opportunity to research on their own very large and very small numbers and present them in written and scientific notation. You might want to keep a bank of these to use later when we create maybe some word problems from their examples, which would be a very cool experience for the students. Provide contextual problems for students to compare numbers written in scientific notation. Again, we're looking at how many times larger or how many times smaller numbers are in comparison to each other, written in scientific notation. And use that bank of numbers created by the students and ask them about how the numbers are related to each other. Have them explore and find those relationships. So let's look at the students. So the students need to understand the benefit of scientific notation. You know, it's a way to write very large, very small numbers, numbers that we wouldn't want to write over and over out by hand. Research to find examples of very large and very small numbers. Again, so they had that context, that the reason why they're learning what they're learning. They need to write very large and very small numbers in scientific notation. They need to be able to do that for sure. And then compare those numbers. When written in scientific notation, determine how many times larger or smaller one number is to another when written in scientific notation. When thinking of some student misconceptions for 8.EE.1.3, students often confuse a very large number for a very small number when written in scientific notation. Usually the result is from the student relying on memorizing a rule. They just think the decimal moves magically without that understanding of why that's occurring. So again, can't emphasize enough concepts before procedures. Students who don't know the properties of exponents, that's another misconception, can also make errors in computing with scientific notation. So again, you might want to spiral back and make sure 8.EE.1.1, they have mastery of that standard in order to teach 8.EE.1.3 to depth. So addressing the misconception, we need to rely on students' background knowledge of positive and negative exponents. Before rewriting the number in standard form, ask students to determine if it's relatively large or small number, and then review those properties of integer exponents. Thanks for watching. If you have any questions, feel free to contact me or your regional specialist, and thank you for making PascoMath more awesome.